Hi everyone, welcome back to the session. In this session, I'm going to be looking at this question, which is called the hardest easy geometry problem. More than a geometry problem, this is a frustratingly simple puzzle on isosceles triangles. If you are preparing for CAT, you should be ideally, familiar with these things. They're just to, let's say imbibe curiosity in a student. Uh, do, do you think this has any application in the actual CAT? Not at all. As a matter of fact, if you are a student of Trident, I will occasionally tell you to, actually don't fall in trap for these type of questions. You don't really require these things to actually crack the CAT. Having said that, let's do something about it. Obviously, you can see that they have given you the triangle ABC, in which angle ABC and ACB are 80 degrees, and they're asking you to calculate this value of x over there. Okay. Now, a couple of things. First of all, because this is an isosceles triangle, it's a symmetrical figure, partly symmetrical. The trick to this question is that somehow you have to design a perfectly symmetrical figure inside this isosceles triangle. A perfectly symmetrical three-sided polygon is a equilateral triangle. So that is the hint or the trick to this question. If you are able to design an equilateral triangle inside this figure, you will be able to solve this question in a jiffy. But the only thing is that there are so many triangles that one needs to visualize. For this question itself, it becomes a little challenging for somebody who is not very equipped with visual this thing. Nevertheless, let's get into it. Let's see if we can solve this. So first thing first, let's appreciate a couple of things. Like I want to draw a line segment from B to CE such that I get a 80 degree. So let me draw it like this. Okay, let me draw it like this. Yeah, hopefully this looks like that line. Now I'm deliberately making this line, let's say BD line, such that I want this angle BDC as 80 degree. I already know this is 80 degrees. The intent behind me doing that is that I want this line and this line to be equal. Okay. And they can only be equal if this angle BDC is 80 degrees. Now if this is 80, that only leaves me with 20 degree for this angle and 40 degrees for this angle. It should immediately strike you that this angle, which is adjacent to the 80 degree, will be 100 degrees because linear pair will make a 180 degree. Okay. Now if you pay attention to the triangle, this triangle, if you pay attention to this triangle, you will realize you have already got two angles as 100 and 40. So the third pair angle will be 40 degrees. 40, 40, 80 plus 100 is 180 degrees. Sum of all the angles in a triangle. Okay. Let's also calculate this angle. That angle is going to be how much? Tell me. You have to be quicker than me. This angle is going to be 70 degree. How? 80 and 30 is 110. So this angle will be 70 degree and vertically opposite angle, this will be 70. That only leaves me with this thing also as 70 degree because 70, 70, 140 plus 40, 180. Can you see that suddenly I am getting one more, I'm getting one more triangle, this triangle. I'm getting one more triangle as similar. So similar triangle, similar triangle, similar triangle. Everywhere you're getting a similar triangle. But now, because I need to calculate for this x, I need to somehow manipulate my values there. So let's start by simply jotting down the values. This is going to be 70 degrees. Can I predict something else? Let's see. If this is 70, can you tell me what is going to be the value of this angle? Obviously, the external angle property will come into the picture, which is in this triangle BF. Okay, let me use a different highlighter. It is actually going to not work that well, right? Yeah, so let's use this thing rather, or maybe let's use a pen instead. So I'm going to talk about this triangle now. Which triangle? This triangle. The external angle to which is 70 degrees. So can you tell me now the internal angle, the sum of the remote interior angles is going to be 50 degrees. Okay. These are a couple of things that you have to see. You have to see the triangles, you have to see everything inside the figure, right? That will make sense. Now let's do some other things. Let's do one more thing. Let's make another construction, because just now I had told you that we need a perfectly symmetrical this thing. So how about let's make that symmetrical line as this one, um, and we'll have to reduce this a little bit. Uh, okay, I hope this is visible now. Now at this point, somebody can say that, sir, this is already 60 degrees that I can see. Can I predict the same for this angle, this length? Okay, so this is 60 degrees. I am predicting this as 60 degree. This is 50. So what will be this length? This length is nothing but 10 degrees. Okay, so this is 10 degrees. I hope that is visible. Now that only leaves me with this thing as 40 degree. Now this is already 40, this is 40. Now this will become 100 degrees then. Instead of using the pink color, let me use a different color. 100 degrees. Okay, hold on. Yeah, so this is 100 degrees, because 40 and 40, that is 80 plus 100. If this is 100, you know very well that this length is coming out as 80 degrees. Which length? This length is coming out as 80 degrees. Now obviously this is 70. I know for a fact that this length and this length is also going to be equal. Why? Because again the similarity will come into the picture, and the triangle will be this triangle. This is 10 degrees, so invariably this angle will be 60 degrees. 60 plus 80 plus x is equals to 180 degrees. That is 100 minus 60, that is x comes out to be 40 degrees. This is the answer to this question. I would not expect a student to grasp this like that, but it's a very interesting question. Not at all difficult if you know where you have to maneuver. That's it. Thank you.